Hey, hello there, and welcome back to another video. So, Advent of Code Day 5, we have a solution for this. By the way, this is a sort of continuation of a previous video, so if you haven't watched that, or if you haven't done Advent of Code Day 5, this won't make much sense, I guess. But yeah, today, earlier today, now it is midnight, so I don't know if I'll be able to actually think clearly, but I don't feel so sleepy, so I want to give this thing a second try. We did manage to get a working solution for both part 1 and part 2, but part 2 solution is, well, extremely inefficient, basically because it is doing a bunch of brute forcing through lots and lots of numbers. So let's try to remember like what this problem is about. You basically have these seed numbers, and you have to sort of, for each seed, you have to sift them through these sort of maps. Each of these blocks is, well, I call them a map in the solution, but I think the description calls them that way too. And in part 1, basically each of these is a single number, has to be interpreted as a single number, like corresponds to a kind of seed. And when you, for example, have 79, this seed to soil map has two ranges. Each line is a range. And well, this first line means the range of seed numbers starting at 98 and of length 2, so 98 and 99, maps to 50 and 51. So this is the destination start and the source start. And so 79 wouldn't fall in this range, but it falls in the second one, which starts at 50, has a length of 48, and maps to 52. So basically it increments by 2, and then 79 would map to 81 basically after passing through this map. If it doesn't match any of the ranges, it maps to the same number. And then, well, it would map to 81 and then map to some other number. When it goes through this, it will be like this represents a seed, then after this map it represents a soil, then after this it represents a fertilizer, and so on until you get to the final map, which represents a location. And then you are asked to get the minimum of those locations. So part 1 solution is something like this. We iterate over all the seeds and we map each seed to its location, going through all of these maps, and then we take the minimum, and that's it. Part 2, however, changes things dramatically because it makes you interpret these numbers not as single numbers but as pairs of numbers, so 7114 and 5513, and these are meant to be ranges. So this would be a range of seed numbers starting at 79 and having a length of 14, and this would be another range starting at 55 and having a length of 13. So 14 plus 13 is 27 numbers in total. And you have to do the same thing with each of those numbers. So instead of 4, you go to 27. And for this sample input, it's trivial. Like it doesn't make much of a difference. It's instantaneous basically on any machine. So we are doing that very naive approach of, for every seed, well, we should take the tuples of two of them, and then we generate all of the numbers, all of the seed numbers starting from this start, plus the length, and then we do the same thing as in part 1, mapping all the way through all the maps to get the final location numbers, and then we take the minimum, and same approach as part 1. And this works very well for the sample, but not for the real input, because the real input has huge numbers here and huge numbers also in these ranges, but that's not much of a problem. The problem is these huge numbers, because you can see like the first range starts at this huge number and then has this length, and this is 400 million something. So we are generating 400 million numbers for the seed numbers for the first range, and we have, I don't know how many of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I think, if I didn't count incorrectly. So 10 of these ranges, and the first one already had like 400 million. This has 20 million. This one has 200 million, and so on. So there are a bunch of seeds, and well, this is very brute forcey. And running this on my computer takes around 100 seconds to run. Luckily, it runs in a reasonable amount of time. I could wait and see the answer in the previous video, but I'm not very happy with that solution because I don't want things to take so long. So now I would like to try something different in this video. So I have been thinking about what to do, but it's difficult to think like just in the abstract, and I get lost in the details. So I think I just have to give it a try and see, kind of have a feel for it. The basic idea that I have is, well, avoid doing this. Avoid generating all of the seed numbers, obviously, because this is the root of this problem. And we should treat these numbers as actual ranges and then do the mapping onto the ranges themselves. The thing is that it's not so trivial to do this for a range of things. And like, when I say range, I mean just keep two numbers, keep these two numbers and consider that, and don't generate all the middle ones. But it's not trivial to do so, because in some cases, some of these ranges will need to be split, depending on, well, I'm pretty sure that they will need to be split, because, like, for example, this range starts at 79 and goes at 14, has a length of 14, so it will go up to 93, if I'm not mistaken. So 93, well, it doesn't fall in this range. I think it falls completely in this range. So, okay, on that case, it's not much of a problem, but you get the idea, right? Like you have some ranges of seeds that we are going to pass and convert them into ranges of soil, and if one of these mappings intersects with some of these ranges, but not completely, like the input range is not contained entirely within the mapping range, then you would have to do like an intersection of those two. And that's not much of a problem. But the problem is that you have to generate both parts of the input range. Like, one part will be mapped, but the other parts still you have to carry on through, because the part that doesn't get mapped, the numbers just stay the same, but you have to keep those numbers. So the thing is that the number of, when you start with one range, it could be split into two, and I think even into three. Like, imagine the case that one of these ranges is pretty big, and one of the mapping ranges is like within the input range. Then what would happen is that those numbers that fall within would get mapped to something else, so that would generate a new range. But the other two pieces would also need to, carry on, and you would need to keep them through. I don't know if this explanation makes sense, but yeah, I don't really know how this will go or how will I implement it, but it's just a vague idea, and I want to like try it out and see what happens, basically. So what I think is let's concentrate first on the sample input, of course, and try to get an approach working with ranges for that. And then we'll see if it works for the actual input, but these numbers are not very easy to look at. This thing starts with the seeds and does this. Let's try something very very simple here. I want to try out, so this is basically what we get here is a range. I first want to see if this assumption that some ranges will need to be split is actually true. So let's try to see that here. Well, I'm flat mapping. I think I won't need to do this. Let's express it as a map. And well, we have the start of the range and the length. What I want to do is something like this. Go through all the maps and map these numbers, the numbers of the range. But let's say let's have mutable versions of this. Mute start and mute end. This sorry, I said end, but this is length. Maybe I should model this with start and ranges, but not for now. Oh, these errors are very annoying. So we'll basically map these things to the start because that's the lowest number, and then take the minimum. And we'll try to get all the transformation for this range. Okay, and this won't be as simple as mapping a single number. We have to go through each map is basically a vector of range map, this struct that I have here. No, not here. Where did I put it? Here. Which has a source start, destination start, and length. This is basically how to map a range of numbers. And where were we? Here. So we will have to map, iterate over all of these ranges. Basically, this function map number and map seed to location, I think this should be inlined into here and have like a explicitly nested loop to see that, but I'm gonna leave that for later. Like I also didn't refactor this this solution after I did it, which I usually like to do. So we are gonna also do this iteration over ranges. Let's see what happens. No, what's I removed all the loop. I meant to put it inside of the loop. So for each range in the map, what I want to see for this range is, let's see if this start plus length fall entirely within the source of this range. Like and if that's the case, then we can map it like entirely and not have to don't have to think about splitting. That would be the best case scenario. So here we're using a method of the range, which is try mapping a number. I guess we could have something similar to try map range, but let's not think about modeling so much right now. Let's just ask if we want to ask if it is within. So, well, yeah, here we have start and length. So if range source start is less than or equal to our start, and what is the end of our range would be start plus length. Is this inclusive? No, it has to be -1 basically to be the end of the range. Yeah. Start plus length -1 is less than or equal to, well, the end of the range. So range, I mean mapping range, I should call it, or something, range map. This is start plus range, no, source start plus range dot length -1, and since the -1 is in both of these places, I guess it can be removed for the comparison. So this would mean that our range start to end falls within this range. So to make things a bit more clear, I want to call this thing range map. Yeah. And now, if this is the case, mapping this thing should be basically very similar to what we do for this, like subtracting the source start and adding the destination start. So start is going to be start minus the range map source start plus range map destination starts, and the length should still be the same. So yeah, I'm not mutating this length, that's fine. Else is basically the case that we don't, well, where we would have to split, or it's also interesting, like there's also the case where the ranges do not overlap, so that doesn't concern me, because that means we don't need to map anything. But this is a problem here. We can ask here if how do we tell if they don't overlap? So if the end of the range is before the start of the range map, or the start is after the end of the range map. So if start plus length -1, this is the end, maybe I should put this into a variable, is less than range map start, or I am noticing that I'm thinking a bit like with some fog in my mind, so maybe I am a bit tired. Maybe I need more tea. Not drinking mate, but delicious tea, just, and not even tea like from the tea plant. It's just some herbs tea. Not to mess up my sleeping more than it already is. So if this thing ends before this range starts, or it starts after the other one ends, so start is greater than range map we don't have an end, we have, and I call it start, but it is source start, and source start plus range map length -1. Yeah, if that's the case, then no mapping is needed. So we'll just continue. We won't change the start in this case. So let's say ranges don't overlap. What else? In this case, it's starts I want some notation for this range, but let's say start length is entirely within range map source range, and in other case, well, to do. So if we don't hit this to do, it should have no problem. So let's run this sample. Yeah, this thing. And yeah, we hit this problem, not yet implemented. All right, let's do some printing, of course, here. And maybe I want to also print, like, where am I? What am I? Yeah, what am I mapping? But let's print, well, mapping range, like what? I'm not parsing the information about which kind of resource I'm dealing with, like if it is seed or soil or what, like, you know, in which parts of the chain I am. Maybe we can do that with this iteration. We could enumerate this and say I don't know, map index, and say mapping range, and I want to say which range, so start length what else do I want? This is already useful. With range, well, with map range, and maybe I could range map, actually it's called, have a debug implementation for this. Let's drive debug. What don't you like about this? What's your problem with this? Drive. Doesn't implement debug. Yeah, am I typing it incorrectly? What's the problem here? Drive may only be applied to, oh, what an idiot. Here's the struct. Okay. Map range. This map range on, what is this? With map, let's here put the map index. So yeah, map index range something. Okay, let's run this. Mapping range 7414 with map 4 we reached the fourth map before we have a problem, and this is length 14, so it is the first one. Okay. The source starts at 77, yeah, okay, and it has a length of 23. So yeah, in this case, the numbers 74, 75, and 76 should not be mapped with this range map, but the rest of the numbers should be mapped. So this mapping operation should leave us with two different ranges to work with, which awesome, I guess. Awesome. Yeah, we have to deal with this. So, well, this is what I imagined, basically. We now have confirmation of that. What I think I want to do is turn all of these things sort of inside out and have these nested for loops be the top level in this thing and iterate, like maybe first generate the initial ranges of seeds, like as a vector of ranges, and then do this like for each map, start with you know, the current ranges that we have, map them all through the range map, maybe generating even new ranges. Yeah, and then what? Yeah, going through that, and then in the end you will have a different number of ranges, and just do this kind of thing, that getting the start of the minimum starts among them. I think that sort of makes sense. So yeah, let's just go for it. So we are going to extract this and turn it inside out, because this is basically something that we can even do for part one, I guess. For part one, where we are iterating over each seed and then basically sifting through all of the maps for each seed. And since the number of seeds don't change, or this, you know, it's 4 in the start and they are 4 at the end, this is fine. But we could also do the other way around. We could map, like iterate over each map and then over each range, and change the seed numbers when something gets mapped. And in the end, you will have, well, they are not going to be seed numbers, but you will have a bunch of numbers that are going to be the mapped location numbers. If that makes sense. But well, yeah, let's leave part one as it is and not think about that. Okay, so now we have this. We cannot have this, of course. We need to first convert these seed numbers into actual ranges. So do I want to model these ranges using another struct? Maybe that makes sense to have another struct called range and has a start and a length. But for now, let's just use tuples. So we are gonna do, this is gonna be a mutable vector. Ranges be a vector of, well, tuples. And this is going to be, no, not U32, it is 60, oops, look at this. What the hell am I doing? 64. And this is going to be the seeds, basically what we have here. We are going to iterate them I just realized why I needed to dereference this. Yeah, it was a stupid mistake. So we're gonna iterate them and have the tuples and collect. Oh, look at that. We have a collect vec method from iter tools, but why do we? Yeah, okay, we do have references, so we need to do a cloned iterator. Cloned. Yep, okay. Let's get rid of this. But what does collect do that's, or collect effect do instead of, like, this is just collect, right? Simply a specification of iterator collect for convenience. What is the convenience of that? Like, if I don't do this, does this work? Well, it doesn't know what's the type of this. I have to specify here the n of these tuples, I guess. How does this work? Oh yeah, it expects, so I would have to say, okay, tuples of u64, u64, and that's not better than the other way. So let's do this, and let's just use our good old collect. Maybe if this can be inferred by the use, yeah, it probably can be inferred. Rust is very nice at inferring things. But anyway, we're gonna go through each map, then through each range map in this thing. And, well, what is this start and length? We have to go actually, say for, let me think of what the hell I want to do. I want to, like, I'm starting with these ranges. After each map iteration, I will have sort of a new set of ranges that might be a different length than the original, like, or the previous iteration one. So how do we do that? I think maybe not with nested for loops. I could have like an accumulator, a vector accumulator, and instead of saying, okay, yeah, ranges don't overlap, so in this case they wouldn't map, like this would be the case where we map to the same thing. Yeah, let's say, let's do with the imperative way. Maybe we can think later of the more like iterator based way. Let's say, let's mute mapped ranges. It's gonna be a vector, let's say, back with capacity of ranges length. Why not? And we are gonna do something, but afterwards we're gonna do ranges equal mapped ranges. We're gonna move this into this, which I think is a safe thing to do. There's probably another method on Rust to do like a total replacement. Yeah, I wouldn't be surprised, like replace or something, but let's do the stupid thing. And in the end we'll have some ranges, but we're gonna get ranges, so iter map. We are gonna have a start and length, well, we are not going to use the length. We're just gonna map to the start, and we are gonna take the minimum out of this. And I guess this is complaining because the start is, oh, yeah, we're also gonna do unwrap or 0. And again, this is still complaining because it's a reference. Just map to this and don't bother. Okay, so now we have an accumulator variable to well, accumulate the mapped ranges. So here we can we could iterate over each range inside of here, or do it in the outside. I don't know which is preferable, so I will do it on the outside. It makes more sense to me. For each range, let's just this structure here. So start length in ranges, right? Iterator. We're gonna do this whole thing. So these are references, sure. The problem with this is that we can borrow, yes, for sure. Sorry. So again, we are now in a similar place, like logically, that we were before. So this is ranges don't overlap in this case. So that means instead of saying continue, what I want to say is mapped ranges. Well, it maps to the same thing as before. So we're going to do push of the same range, start and length. And then we could say continue, but we can also do an else if. In this case, start and length entirely within the range. Yeah, okay. So what is this case that we are doing? Well, we are going to, we were changing the start before. Now this will be like the start of the new range. Let's say let's mapped start, or like destination start, we could say. No, mapped start is fine. And we're gonna mapped ranges push this mapped start and the same length as before. Okay, so I think that is a good conversion of what we had. We should still hit the same problem as before, but now we have a very different structure. What I want to say here is let's print this also. Print line, print. Yeah, my brain is definitely foggy. Ranges after map index. Well, actually this is mapped ranges. Let's run with the sample and let's see what happens. Ranges after 0. Oh, I just put a $sign there. Oh, I'm messing something up, right? I'm multiplying something because I had 4 at the beginning, and that's fine. No, that's not fine, right? why do we have 4 ranges? We're not clearing the... What is going on? Do I have to clear this? Because this means that the thing gets moved, right? So mapped, and this is just a local variable here. What am I messing here? Ranges dot clear. Do I need this? No. Am I? What are these numbers? So 79, 81, 55, 57. We are mapping what the hell is happening? Like, I'm sure if you're watching, you probably have already seen my mistake, but what am I doing here? Let's not print here. Let's print at the beginning. So ranges at iteration this. We're gonna just map this. And well, let's, you know, we can do the double printing. After this iteration is mapped. Oops. Actually, let's move it here and just print ranges again. So at iteration 0, it's already bulked from the beginning. No, at iteration 0, it starts well. Then after iteration 0, it's like we have pushed this. What? And then we have the original and we push the other. How are we doing that? Does that have anything to do with this? We are pushing. Oh, I see. I made a stupid mistake, I think. Yeah. So we are trying for each map and we are deciding like we shouldn't be pushing here because we are iterating each range map, and this is not what we need to do. If we don't overlap with any range map, that's the problem. Oh man, this is more complicated than I originally thought about, I think. Huh. So, you know, I realize what's the error that I make, but it made me also realize that it's much more complicated because, like, a single initial range can, of course, like a single of these can overlap with many range maps. And in that case, it can be split into like many things. And so, what are we going to do? I guess if we originally tried to map with something and it doesn't overlap, then if we split when overlapping with something else, I think we should be kind of safe in that case. Yeah. Man, this is difficult. Yeah, the thing can be split. It is more difficult than I thought. So how do we express this? Because basically the problem is, forget about this repetition that we just found and it's stupid. The problem that I now realize is, imagine you have like a big, where's the camera here? A pretty big range of this kind, like the one that you are mapping, pretty big, and then you map a chunk in the middle of it, or even like, we don't know if that case happens. Actually, we shouldn't assume. Maybe it doesn't happen. And if it doesn't happen, then what? Like maybe I'm overthinking and like multiple ranges overlapping with the same is something that may not happen. Could be. In that case, it would keep things pretty simple. But this is I don't know, I find it really tough to think about. So what should we try? We are mapping this range with all of these range maps. So if it doesn't overlap, it doesn't mean that we have to push this range to the mapped ranges, because we're going to try the same thing with many range maps. So if none of them overlap, then we're going to map multiple copies of that, and that's wrong. And if it is entirely within, this case is also interesting, because it means that we have basically like consumed all of them. We have mapped all of this, so we are done. We should break out of the loop here, like for sure. And in this case, we need some way of knowing at the end of the mapping process if we mapped anything here on start and length. So what should we do for that? Maybe we can sort of like mutate this thing and kind of consume it. So leave it at length 0 after doing this, and if it's not length 0, like, yeah, that could work. Let's try that. Let's actually remove this thing, and let's say, let's mute start and length. It's also going to be mutable the length, but let's start with this, start and length. So these are copies. Does this work? Oh, this cannot be referenced. So yeah, let's take a borrow of this. Don't bother me. Okay, so, oh no, actually, I want to mutate the length. It's entirely within the range map. Source range, yes. So we push this, and we say, hey, we have consumed all of the length. So length is going to be 0. Beautiful. And after this for loop, if the length is 0, then we're going to say mapped ranges push. But I lost the... Oh, no, sorry. If length is not 0, so we still have something that we haven't mapped, then mapped ranges push start and length. That's what we want. And here, if they don't overlap, I can just continue, because I'm not mapping anything of this range, and I'm not and yeah, no, I can just continue, I think, in this case. So, okay. How does this look now? Okay, they are not exploding, at least. We are keeping at 2, that's fine. So, in the beginning we have this, and we map successfully with this. Then at iteration 1 we start with the same thing. So it wasn't the problem of like messing up. I don't think that we need to clear here. Like that was done. Yeah. Okay. So on iteration 1 we have 81 and 57, and they don't get mapped to anything. Is this correct? Let's look at the sample. Soil to fertilizer is iteration index 1, and 81, yeah, no, it won't match with any of these. These are much lower numbers, and 57 doesn't match with this, nor with this. So, okay, no, this don't map in iteration 1, that's correct. On iteration 2, we have this is the case, like 57, and this is iteration 2, so it is this thing, and it is the 53, this one. So it starts with our map is 5713, and this is starting at 63. Is it the same thing that we had before? No, before we hit another case, we reach deeper, but now we are iterating things in a different order, so we're hitting a different case. But is it similar though? So 57 of length 13. The source start is 53 and its length is 8. So only a couple of things. So this goes up to 61. So it's only 57, 8, 9, 60, and 61 of these 13 that overlap with these. Okay, so that is an interesting case, and I think we can try to implement those. So the only case that I'm fearing is the case where a big, and actually I shouldn't be fearing that. Yeah. Let's not fear. We're all iterating over this. Sure. We have to map each. Yeah. I have ideas of how to deal with things. So we have to consider more cases. Basically, we have the two most simple cases where they don't overlap where this range is entirely within the other, and now I want other cases. So let's say if well, let's leave this else intact, and I want to have another if condition here, something and blah, and this is gonna be else and that. So if now we know that it's not entirely within, so we know that there is some overlap, because otherwise we would have continued after this. We know that it's not entirely within this, entirely within the mapping range. So I think that there are three distinct cases in here. Did I actually put the length of this correctly? So source, if the start is less than or equal, so equal is included, and then this plus length is less than or equal. Okay, yes, I think, yeah, this is correct. So now if let's say start plus length minus 1, which is our end, is less than the, what do I want here? Now let's say if we are starting before our map, our range map source start, we're starting before. If that's the case, I think that's the only condition that I have to check here. If we are starting before and there is some overlap, it means that it's a case like this. You have this range and it's starting before this other one, and they overlap only on one part. So what are we going to do in this case? Well, we're gonna modify this range that we have. So it starts before our mapping. So, and I think that is exactly the case that we are hitting here, right? This is 57. No, it doesn't start before. It's it ends after this thing ends. So this thing ends at 61, and this thing ends at 70. So it ends after, and it's the other case that we have to check. Let's imagine first the starting before. So what we are going to do is change the length that we are dealing with and say this is going to be I think it is the difference. So imagine that our start is, I don't know, at 3, and this thing starts, let's put a comment here, and this thing starts at, I don't know, 5. It means that 3 and 4 are not mapped by this range map. So our length is going to be just simply 5 minus 3, right? So range map source start minus our start. That's going to be our new length. I think, but before doing this, we want to push like a part of a mapped range, which is gonna be what is like, we have to make the sub range that we are going to map, and that thing starts at the source start basically, and let's say I don't know how to call this. let's trying to think. It's difficult to think. I need more tea. Let's call this thing like the intersection, but it doesn't make sense. Like, no, I don't think so. So what we want is basically mapped. Let's express it. The final thing that we want to add a new range that will be mapped. And the start of that range, which is at the range map source start, is going to be mapped exactly to destination start. That's correct. So range map destination start, and the length of this thing is basically the difference of this new length and what we have in the beginning. So yeah, let's trust what I just said, and well, let's say length minus this whole thing. So it's gonna have this. Does this make any sense, what I just wrote? Length minus the, well, this could overflow, I think. So we know that start is, let's grab this and put it here, length plus start. So start minus range map source start is gonna give us the, isn't that a negative number? No, it is not, because start is less than that. No, so it is. Oh man, it's so difficult to think. But okay, that's a negative number that we are gonna be putting into length, adding to length. So what did we have before? We have this, so it's like saying minus this. So I think we can express it the other way around. Minus start, man, I don't know if this makes sense. No, wait. Let's trust our gut. I'm not really sure if this makes sense, but let's go with it. Map ranges. What I need to do here is push. Let's actually see what happens after we do this, but this doesn't affect, like, we are going to hit the same case that we were hitting before. Damn it. Length plus start minus, yeah, okay, let's leave it like that. We're gonna have another else if, whoops, that's gonna do something kind of similar. That's not quite. If the end, this is starting before our range map, and if it ends after our source our range map ends, so this is start plus length minus 1 is greater than this, or start range map length minus 1, and the minus 1 is repeated in both cases, so it's not either, so it ends after. What don't you like about this? What's identical blocks? Clippy, what are you doing? If has identical blocks, cargo Clippy, tell me what you're seeing. Yeah, this is fine. This if start. Oh yeah, the block inside the if. That's an impressive lint actually. Not so impressive now that I think about it, but it's nice. But let me think about it, Clippy. I'm writing this thing. Okay. So now we have the other case. This now ends before this thing, the mapping ends. So now the start of the range. Wait, I don't know if I did the previous one correctly. In fact, I think maybe I did. But now the start of our range is within the range. So what we need to map it, and to map it, we're going to do just copy this and not think too much. Now the bodies are not the same, so go away, Clippy. And the length, what about the length? The length is going to be, well, let's think about the final length that we want. It's gonna be from the range map end. So let's say, again, let's consider an example. Let's say that the range map ends at, I don't know, 5, and our range, which ends beyond that, ends at 8. So we don't have like nice expressions for the ends of things. So I'm considering that it would be much simpler to express these ranges as start-end ranges and inclusive, and not have to deal with lengths. But let's plow through with this, and then we can think about refactoring. So in this case, the new length, like what is outside, will be this. We said that the mapping ends at 5, so 6, 7, and 8 fall outside of the mapping. So the length will be, we have to modify the length and the start. So the start will be the end of the range map, well, and that is source start plus range map length, and this is one more than the end, so this is fine. This is the new start, and the length is going to be the end of the range map. So this is -1 minus the end of our map, which is start plus length -1. Okay, and we can simplify things. We can get rid of this minus and change. Is this correct? Yeah, I think so. This would be +1, but with that other -1, they should cancel out. So something like this, I think, should make sense. and the parentheses. Okay. Again, I don't know if that made a lot of sense, but I think it should take care of the case that we were hitting before. So let's see. At iteration 2. Oh, subtract with overflow. That is amazing. Where did that happen? In here. So here we are in the case where our range ends after. Yes, I think I thought this the other way around. So let's say that our range starts at ends at 8, which is bigger, and the range map ends at 5. That is the case that we have. So yeah, the start being at the end of the range map +1 is fine, but the length should be ours minus this. So let's say basically the other way around, change all the signs, but start plus length, and this would have a -1, but it's gonna cancel out with the other -1 from the other thing. So does this now work? Oh, look at that. We did have an answer, which is 0. Okay. Is that because of this? I don't know, but we got a bit of an explosion of ranges. Oh, no, I didn't mean to do that there. I have to do something about the console and my face over here. Maybe I could use the other console, which still has the thumbnail from before. So if we do cargo run, man, I cannot type this thing, not with the input, but with the sample. What do we get? And y is 0. Well, we have a range that starts at 0, but that's not the correct answer. What was the correct answer for the sample? 46. So we are kind of far from that. So okay, in the iteration 2, we started with this. Oh, one thing that we could do to sanity check is to see if we still have 27 things at the end. So iteration 2, here we have 14 and 13. Then this doesn't get mapped to anything, that's fine. And this has length 17, so 13. So that's definitely wrong. So they got bigger instead of smaller. So that is that's concerning. So let's try to understand that thing. We have the sample here, and let's maybe do something like, whoops, put it here. Look at this beauty. Yeah, we are looking at this. Iteration 2, we have, maybe we can trust it, 81 and 14 on this map. Oops, let's put it always on top. So, where are we? Here, 81 and 14. So 81 is bigger than this, and it's bigger than this plus this. So yeah, it doesn't map to anything. That is fine. So we are leaving it be. Then we have this 57 and 13, which does overlap with this. So in this case, we should then have what's happening here? 57, 13. What should we end up with? We should end up with a piece of this that goes from 57. So this is 53 up to 61. And it will map these things like 4 numbers down to, because 53 maps to 49. So can we see that? I'm having trouble. Yeah, 57 is mapping to 53, which is fine. Yes, it's fine, but the length is wrong. And then the rest, so 57 up to plus 13 is 60. It's not 61, right? What's this 61 doing here? I'm not really sure. That's concerning. Yeah, I surely messed the calculations. But how? Man, this is difficult to interpret. A friend of mine said about today's puzzle, I hate interval math, and I have to say, I think I hate it too. But I only hate it because I'm so bad at it. So I don't understand why we end up with 53 here. I think that's already a mistake. So the 57 overlaps with this. Like this goes from, maybe we can write that down, change the input just a tiny bit. So 50, this is basically the same as 53 up to plus 8 is 61. And we are going to say these are inclusive. Let's write it like this. Okay, so the overlap of this and this is basically 57 up to 61. So we should have 57 up to 61 mapped 4 places down. So yeah, 53, which is confusing. Okay, so I think this 53 is actually correct here, but it doesn't have to deal with this 53. It's just 57 minus 4, which is okay. But what's the length of this range? So it is 7, 8, 9, 10, 11. It's 5. This should say 5 over here. And then this would go from, not from 61, it should not include 61, it should start from 62 and have a length of 8. So it's basically all pretty wrong. The only correct number is 53, but this should be a 5, if I'm not mistaken, and this should be 62 and 8. Great. So we did screw things over, but let's see now where is the always on top thing? Here. Okay. What went wrong? So we are in, which one is the case? Where we end after this. So we should be here. Should be here. And we are changing this start. This is not correct. So source start plus length, what does that give us? Source start is 53 plus length is 61. But wait, is 61 included here? I don't think so, right? I forgot to do a -1 because that is 63. I am saying 60, but it's 50. Sorry. 53, 4, 5, 6, 7, 8, 9, 10, which is 60. So no, this goes up to 60. I'm very sorry. I did the calculations wrong. So it is actually correct. This 61, it is actually correct. These two are correct. What are wrong are the lengths of things. Okay. So this length is wrong and this length is wrong. Great. Why does this length not change? That's weird. So what are we subtracting here? So it is the way that I want to think. Oh, I think it is because we modified the start in the beginning. If I turn this around, I think that's why. We're not using the length here. Let's see that. We still have the other length wrong, but oh, I also screwed this. Let's run now. Do we have different numbers at iteration 2? Yes, we have a 9, which is correct. I think I was confusing. It wasn't 5 and 8. It should be 4 and 9. So this 9 is correct now. The 61 is correct. And this 17, which seems to be 13 plus 4 for some reason. So we did screw that up. So this, what's up with this length? This is the length of the piece that gets mapped. So should be the original length minus how, like, the intersection, the length of the intersection between the two maps, and the length of the intersection. Oh no, this is the length of the intersection, what we want to put here. So it's the original length minus this length that we are computing here. If this length is correct, of course. So let's trust that it is correct and just paste it here without, actually, I think I just copied this from the previous one. I didn't modify it, right? Yeah, that's probably completely wrong. And that's stupid. So we're gonna do minus this. And this includes our length. So this length can go. If length minus length is going to nothing. So that is, and we can put minuses on all of these. So this will be minus start class and plus. And we don't want to do an underflow, so let's move this to the end. And let's see. This is range source start, range map, plus the length, minus the start of our. How does that work? I don't know. But let's see if actually we have already thought about this second iteration, and actually I'm seeing the 46 here, which I think was the correct answer. Okay. Yes, we have 4 and 9, and those are the numbers that we wanted to see. So that's great. And just as a sanity check, let's see how many things we have in the end. We have 1 plus 10 is 11, 14, plus 4 is 18, plus 3 is 21, plus 4 is 25, plus 2 is 27. So we have kept the number of things, and the answer is 46, which is what we expected. Yes. And so if we actually now run check samples, no, it failed. Because we have a lot of output, but we can suppress this output, of course. So goodbye. Whoops. If we run now, what do I want to run? This I want to run. We have more outputs. Let's suppress it. And now it passes, okay. And now the real test, which is to run with the actual inputs. I'm going to run in release mode. And okay, let's hope that we don't hit this case. Fingers crossed. And we didn't hit that case, and we did get an answer. And actually, yeah, wait, we can check the answer. What was the answer? Answers.txt. It's not correct. Damn it. So this is 37 million something. And this is 77. It's in the same sort of order of magnitude. But we didn't get it right. So if we do a check all, with that check the inputs, it's not correct. Oh shit. This is the worst case scenario because the sample passes now, but it seems that we have made a bigger mistake. This to do should run in debug. Sorry, yes, we are in debug mode. And the to do is not the case. Well, at least it's not the case that happens. So I'm happy for that. Let's clear these stupid comments and these. And what an ugly piece of code this is. I'm pretty sure that if I used start and end ranges, it would be much better. But let's not think about that. How could I have screwed up? We know that for a fact that this case happens on the sample, but does this case happen? So if we do, let's say unreachable here, I don't know. And yeah, there's a warning there, but let's run this with a sample. Yes, enter unreachable code. So it does happen in the sample too. So presumably, this is doing the right calculation for the sample. Otherwise, we wouldn't have kept the lengths correctly, I think. This is where the start is before the source starts. Oh yeah, so we keep the same start and we put the destination start here. Okay. Okay. So one sanity check that I would like to do is to print the number of elements, like the length of all the ranges after each iteration, after each of these iterations of the whole maps thing. So after this, let's print line, total length is gonna be something kind of similar to this, mapping things, and we are gonna sum into, I don't know, 64-bit number, but we are going to map the length. I'm not gonna use the start. Map the, sum all the length of the ranges. So if we run this with a sample, it keeps at 27. If we run this with actual input, well, we actually keep the same number. So we are preserving total lengths. That's awesome. What happens if we bring the other print messages back? So after the iterations, I guess, I don't need to do the repeated things. Woohoo! We have lots of things. So let's run here. Oh man, this explodes. At iteration 0, after at, that's good English. This is kind of exploding in. There's a lot of things going on here. Huh. But I mean, we are not hitting the worst case scenario where what will be the final else here if it's basically if the mapping, so here we are saying if ours starts before this or it ends after this, but then the other case that we are not checking is if it starts after the range map and it ends before the range map ends. So in that case, no, actually we are checking that. Right? That's the case that they don't overlap. Is that correct? No, it's not correct. That's not what we are doing here. Yeah, it's basically the opposite of this. If what we are doing in the second condition is that if our start is after this, but what is the other condition then? I'm now confused. I'm not sure if then if we've made all the correct logic here in the if-else chain. So what is the condition that I'm worried about? Let's spell it out and see. What I'm worried about is that the range map is entirely within this range. So let's check this. If, because I'm not sure if that is the else that we have here, because I got confused with all of that thing. So basically what we are checking is if start is less than range map source start, so the source start is after this start, and range map source start plus range map length -1 is less than the end of start plus length -1. The -1s again go away. And if this is the case, you're gonna panic and say, oh no. Okay, And if we run this with the sample, I hope that the sample is not hitting this. No, because we got the correct answer, but that's the actual input. Oh no, it does hit it. Okay. And we were not finding this. It's not the... Okay, so we really screwed up some of these things. Some of these conditions. So this is happening. This is happening. Great. So this is the case where we have to basically split our range into three. The first part that doesn't get mapped, the middle part gets mapped, and the ending part doesn't get mapped. So that's a problem. And why didn't we... I think I should end the video. I think it's been an hour and a half or something like that since I started, or even more. But I feel like we are almost there, kind of close. Maybe we can, I don't know, do something horrible and make it work. But I want to understand where did we screw up? Because like we have, well, many conditions. The first one is no overlap, okay? No question about that. The second one is where our range that we are mapping is entirely within, so that should map all the thing, and that's fine. And we change the length and we are happy. And we even break because we have no more things to map. We are breaking out of this loop and we won't fall into here, so that's good. Okay. So these two ifs are fine for me. Then if none of these two were true, so that means that we do have an overlap and we are not entirely within, like this thing is not entirely within the other range. We should give better names this too, but within the range map source range, then and we do have an overlap. If it starts before, oh, we basically have, okay, so it will start before. Ah, yeah, we are, I think, losing. We are, yeah, I understand. It could happen that it starts before and it ends, it ends afterwards, and we are not checking for that. We should, and we should check for that. So basically that is start before. This is the same condition as this, right? Yeah. And this is the other condition. It should be the same as this. I don't know why we... Okay, yeah, it's the same as this other one, but turned around. The symbol, but it is the same condition. So this is actually not the whole story. Can we simplify this some other way? Like maybe split the range and like continue or something? What a beautiful case this is. So I want to not think about things. Let's copy this, even with the oh no, and move it where I think it would make sense, which is here. For anything else, we should still be hitting this, but this now should really be unreachable, unless I am like very stupid. If we run this now with an input, we hit the O, no, great, and we can maybe print the case. Print line. Actually, didn't I have, yeah, this is what I want to print. These are going to be big and ugly numbers, so it's not really pretty to see, especially like we have length to calculate, so this is definitely not a good case. And it is, it's very unfortunate, like the sample input doesn't cover this bad case. But anyway, we have this range that starts at, I don't know, 400 million something, and it is 320 million long, and yeah, the source start is at where 500 million and the length is quite small, like in terms of this giant range is 56 million. So this thing, source start plus this length, is entirely within this, and we have to split this thing into 3. Beautiful, beautiful. I think we can do, maybe we can cheese it a little bit and split the end of it, push it into ranges to be processed, but we cannot push it into this range ranges variable here because we it is mutable, but we are iterating over it, so we cannot have to reference to that. Of course, it will be like you cannot modify something that you are iterating over. That's I don't know if undefined behavior, but something that shouldn't be possible. But there are other ways of doing that, and I will surely do so. But yeah, if we snip the end, then I guess we can then use a very similar logic to this case where it starts before and we just not care about the end. I think so. But well, let's think. What do we have to do here? We are going to push a mapped range, that's for sure. The length of this mapped range, since that is something that I know, is going to be the length of this. And the start is actually something also that I know is the destination start. So that's actually the easy part here. The easy part. We are going to be continuing with these. I think it's also pretty easy what we are going to be continuing with, but we also have to consider the rest of the range, which is basically analogous to this length and start of this last case where it ends after. But that is, yeah, let's copy these, but I don't want to assign these things. This is basically going to be a special. This tuple is special. So what is this tuple? This is the tuple, like the range start plus length minus, yeah, sure, This is the thing that I also want to keep iterating. So let's think about that. We have to change the way that we are iterating things here. Instead of saying this for in ranges iter, what we are gonna do is to consume. To use ranges will be how do you call this thing? A stack or something that we are going to consume. We're gonna push and pop. We change the order of iteration, but the order should not affect our solution. Although, well, it could. So let's not change the order. We're gonna make the ranges be, instead of vec, it's gonna be a vec deq. So far it should be the same, but vec deq, well, the mapped ranges is this. That is fine. These are the mapped ranges. Okay. Yeah, let's make it a vector queue. Why not? No problem with that. But instead of push, we need to say push back, I guess. So push back, not bask, back, and push back. Okay. Yeah, what happens if I not do this and we run with the actual input? We're still running. We get the same erroneous answer that we got before. Okay, good. If we do this, hey, the Rust language server kind of gave up with that. What's happening? Oh, Visual Studio is no, don't worry. That was funny, like just uncommenting some code made it choke. Sure. What we need to do then, what was I thinking? Yeah, we are not going to iterate like this. We are going to do a while. Where there is some starts and length in ranges, and we're gonna pop from the front. I just used a vec deq to preserve the iteration order. So cannot. What's your problem here? Well, let is what I want. And this is okay. Since we are popping, this is fine, great. And we are popping, so I'm guessing that since we are popping, we can mutate this thing. No problem with that. Can I say that's like, let's mute here? Yeah, well, let's not do more than like, let's not get creative right now. But I'm sure that's possible. Now we are popping, and we have this for loop that ends here, and everything that we are doing, we are pushing into mapped ranges. That's great. We will have consumed all the ranges, and then we assign map ranges back to it. So we have ranges after iteration. So all of that seems good, I think. Let's try again now with the queue in place. If we run this again, we should get the same answer as before. Yes, we do. Sanity checks. But now with these, I meant to use a vector queue because now we can pop this back into the ranges to be processed. So we have the mapped ranges, and we push this into the mapped ranges, sure. And then we're going to be pushing this into ranges. Push back. You can push it back or even push it front. It shouldn't matter, like it shouldn't really matter. Great. Great, and then we modify the length. I'm not sure about the calculations, and I don't know, but let's run now. Woohoo! Look at it go. So we entered an infinite loop, it seems. Well, that's not correct. So what did we do wrong? Just pushing back is the problem, right? If we do this, yeah, we do that, and we even keep the... Is this the same erroneous answer as before? I think it is. So if we do this beautiful, beautiful thing that we are doing, 672. 672, okay, yes. This is doing basically exactly the same as this case, I think. We're modifying the length, sure. So here we are keeping the start, and the end part that we have is starting at start plus length. Why is it doing this? Y minus. It should be just start plus length, right? Oops, what? I just went to some definition or something. This is wrong. This. Why? What did I do here? Where did I copy this from? Oh, this was the length. Oh man, I'm an idiot. And this is the start. I just switched. Nothing. Let's run. Is this the correct answer? Yes, it is, right? Let's check all. Yeah, it's failing because of all the extra things, but it is the correct answer. Damn it. It was so... like, I made so many stupid mistakes. This we can get rid of. Can we check all? We have more printing. What are we printing? What is it that we are printing? Doesn't the check all? Okay, yeah, now it passes. Great. And there's something going really wrong with my Rust Analyzer and VS Code because I'm not seeing these warnings, right? If I close this and I go back at it, do we see? Well, but we made it. We are... I'm seeing this error here, but I cannot... Can I move it around? My face is on the way. I will move my face a little bit. You don't see, usually have a window with my face underneath the OBS. Yeah, it's saving, it's running Rust Analyzer, but it's taking a lot when saving a file for some reason. So you know what, I'm going to kill VS Code and let it die and open it again, because this is computer science. We fix things by killing them and restarting. Like, it's really weird that Rust Analyzer will joke with the amount of code that we are doing in Advent of Code, but it seems it did. Now I have this unused variable warning, so that's fine. We can iterate without enumerating here, which is what makes sense. And yeah, now if we run the actual thing with the input, it just spits the output immediately, no problem. And it's just this beautiful, beautiful code that we have produced. That is great. I definitely want to now refactor this, but not now, because it's 2:40 a.m. and I am pretty like my brain is pretty toasted. But yeah, we actually managed to get this working. Great. With horrible code, but no problem, it is working, which is what matters. So how much of a speed up did we get actually? So we're running this in debug mode here. I want to build cargo build release and time targets blah 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 blah, but day 5 with input day 5, yeah, input txt. If you run this now, look at that. Like the first one was the best, 1.7 milliseconds. That's great, and some of that time is probably like the startup time of the program. Like the computation is so much less, but that's a huge. So it used to take 100 seconds, so a minute and something, a minute 40 seconds, and now it takes like 2 milliseconds. So how much of a speed up that is if we run the calculator? I use the console, but I also use the calculator. So if we do this divided by 1.7, is this the way that you do? Yeah. This is the previous time of amount of milliseconds, and this is the new time. It is a 58,000 x speed up. That's great. We can, yeah, let's round up this number. Actually, let's say it's 2 milliseconds. So it's a 50,000 x speed up. This goes 50,000 times quicker than our previous solution, and I think that is a pretty good clickbaity. Oh, I think I now understand actually this sort of tiling thing that I think Genome is doing now, which is kind of great. Let's show the beauty of our code here in very small font face. This is completely unreadable, I guess, but just to show the beautiful shape of our code. And here I'm going to do a toilet for a thumbnail. So this will be AOC yeah, let's use the same thing, but just as a clickbaity title, let's say 50. Now this is American English, so X speed up. Oh man, I always have trouble with. Oh, look at that. Is it still readable without the commas? Yes, this is still readable. So that is a clickbaity thumbnail title, but it's not a lie. It's actually wrong, not actually correct. Just that we stopped doing brute force. So actually, we could say that as like day 5. Let's say no brute force equals, or I guess we can say equals down here. Oh, I screwed up. No brute force, new line, almost there. It's too big. Let's say AOC day 5. Yes. Okay. No brute force equals 50,000 x speed up. And to be honest, I don't like shouting, so let's say speed up with lowercase. Clear the screen. That is a thumbnail. I'm even tempted to do like the surprised face of like YouTubers that is so annoying on thumbnails, but I won't do it. But I really like this, so I do want to put at least an exclamation point and maybe clear the screen like this. But the exclamation point is going down. I am bike shedding the thumbnail here, but bear with me. I think it was better. Why doesn't it? Yeah, when I think this is no brute force equals 5,000 x speed up, and let's run it some more times for a nice color. That is a nice color, I think. It goes red on the speed up, so that rocks. Okay, and here on the right, albeit a bit small, oof, look at that effect, awesome. You can see the beautiful shape of the code that allowed for such a speed up. It's so ugly. But yeah, that is it for this video. I hope that if you reached this part, you have enjoyed something. I definitely enjoyed hacking at this problem and finally solving it, at least. You know, it's horrible code, but it does work 5,000 times faster than before, measured with science. So that's it for today, and see you later, I guess tomorrow, on the next Advent of Code puzzle. Bye bye.